Hello, everybody. I am Yamshid Farhat from BKW, and today I will present you our work on in-house and external artificial intelligence and machine learning solutions. I am working as a data scientist on grid analytics at the Grid Digital Solution Department on the Power Grids field. And my role on BKW is regarding identifying potential use cases where through advanced analytics, automation, and AI, we could enable a more efficient and reliable distribution network. Then at the same time, on my department on digital solutions, we develop and deploy and operate these solutions. So today in my presentation, I would like you to present our journey. Let's say, how did we start? What did we learn during the way? And where we are right now, which projects are we working where we can use in-house or external AI and machine learning solutions. So great. In order to start, I would like to explain you a little bit about BKW. BKW is an electric utility that operates on the canton of Bern and Jura in Switzerland. And we started really long ago. In order to support our industrial revolution here in Switzerland, we start to build the first hydropower plants in the country. What we have seen is that during the last 125 years, we have transformed a lot. And one of the biggest and best examples is our nuclear power plant. We were the first one who built a nuclear power plant in Switzerland in 1972 in Mühleberg. And last year, we were the first ones to decommission this nuclear power plant. So this is also the first decommissioned nuclear power plant in Switzerland. And we were also the ones who did that. And then at the same time, we are looking to a new future, more decentralized and with fluctuation energy production. And of course, with a much more complex environment that we need to deal with. And for this purpose, of course, we are actively managing our digital transition, because we really need to identify and develop these new solutions where we are working specifically in my department. And we want also to ensure that we create value from this digital transition. We want to protect and expand our know-how, so we are capable to develop new solutions. And also we want to actively involve our management, because we are well aware that by ourselves, we will never be able to reach all our goals that we have set. How and when did we start with artificial intelligence? We believe that we start quite soon in 2013, when we created our smart grid department. Then we had as a main focus the development of new solutions for a more efficient and reliable network. What we wanted to do is providing new services. And we started looking towards in-house solutions, so we can profit ourselves, but at the same time offer as a service to other utilities. And we started specifically working on demand-side management and real-time grid optimization. I would like to talk a bit quick about these first projects. On the first time, we profit from our Swiss environment, where since 1916, we have an infrastructure that allows us to control the boilers and heat pumps of almost 100,000 customers, with what we call ripple control, or RSA in German, where every night we send a signal to these elements, and we decide when these boilers should turn on. So it was always statically, and we decide that we could optimize this through an optimization problem using artificial intelligence. Then what we did is that we built a model where we could identify from our substation energy profile which energy was consumed by the boilers. We could identify the pattern and build our model on it. Once that the model was built, we could optimize the energy based on the day-ahead price. We could set which group of boilers should be activated at each time. And then we could implement it and also offer this service to their customers here in Switzerland, what allowed us to save almost 500,000 per year. At the same time, we built other type of products based on machine learning directly for our prosumers. We believe that with the same infrastructure that is existing in Switzerland, we could manage the boilers of customers who has solar panels in order that they can increase their self-consumption without requiring any additional hardware or intelligence in their system. What we did here is that using the weather forecasts, using our existing solar profiles datasets and customer consumption datasets, we built a random forest machine learning algorithm that every day could define if the boiler should be turned on during the day using solar energy, or it would be optimal to be turned on during the night on the lowest tariff price. On the other hand, we also try to build a complex and advanced monitoring platform where we can install advanced measurement devices into our network in order to fulfill this process. One side, measuring every state of the grid every single second, defining the state of every single element and component on the network, and then control the available generators and loads in order to optimize our system. For this purpose, we decide to work on an on-prem platform where we build in our infrastructure, where we built a Hadoop system built over 2 master nodes and 4 worker nodes, where we had also one management node and one edge node where our data scientists could work directly on R. Our first results were really promising, where we were able for our customers to improve or optimize their energy consumption. They were able to use their own solar energy and not inject it on the grid. And at the same time, using our monitoring platform, we were able to optimize the power quality of our network without requiring additional investment on infrastructure, let's say new cables or new transformers. So we were really excited about that. And we could see that we had a huge expectations with our first projects. We believe that based on our big data platform that we built in our system, we could build a huge know-how that allow us to be innovative leaders in Switzerland. We believe that, and we were sure that we could fulfill all the data compliance requirements, that we were flexible, we wouldn't require any external support, and that other utilities could profit from our development. On the other side, on the applications that we built, we were sure that we were reshaping the future of distribution networks with these solutions that we were developing. And of course, that the know-how that we were building would allow us to develop much more new solutions. But what we faced was, on one side, that the reality was that the on-prem platform had really high capital and operational costs. From the capital side, we had to build a big infrastructure in order to avoid scaling problems, because we could not pay just for the resources that we use. We really needed to build the resources that required to be used for the biggest calculation. And on the same time, we didn't have so many IT specialists that were able to running and operating this type of platform. So we were really dependent on our own experts. And for changes, for updates, had a big impact into our processes. So we were not flexible as we were expecting. And on the other side, regarding innovative applications, the reality was a bit different than we expect. The know-how that we built was undoubtedly so much a success, and we could earn a lot from that. But the reality is that the solutions that we developed couldn't really reach a positive business case with the actual regulation, except the first demand-side management business case that we showed. And the products that we were working on it, they were not developed or weren't available because no positive business case was identified. So that make us really evaluate what we did in order to identify how we could become better and not to do the mistakes that we did in our first implementation. Because this, of course, is an iterative process that we need to improve every time that we develop a solution for our customers. And what we have seen and we have learned is that the first and most important fact is that by yourselves, we are not able to reshape and to implement anything. We need to involve every single stakeholder of our company. We need to include the subject matter experts into our group. We need to involve the electrical engineers because, of course, we are operating an electrical network, and our GIS specialists because our network is geographical and topographical set. So we need their knowledge. And in addition, we need to be able to communicate together these standard experts or the experts that have been working for the company for the last years with the experts that are coming through this new digitalization revolution that we are experiencing today. So we need really to build a breadth of knowledge, but also a depth of expertise and work in an interdisciplinary way and as an agile cell, because we believe is the only way to survive. Furthermore, flexibility is not just an issue as a team, it's also an IT requirement. We need to be flexible in order that we can be efficient and in order that we can set optimal solutions. So for this, we really start to look into cloud solutions because cloud allow us not just to pay for the resources that we use, but also at the same time to scale our problems. So being flexible enough to know that we won't have restrictions based on our IT infrastructure, and also on the same time be sure that we can fulfill the security issues that Microsoft, Google, Amazon are investing so much millions on it, and that we can profit from every single provider, that we can also achieve and reach a multi-cloud strategy if we aim for that. So it really allows us to deal with the flexibility issues that we had on our first projects. On the other hand, we believe that monolith solutions have a high operational cost for our type of business and don't allow us to develop and deploy new solutions in an agile way. So we believe that working with a microservice architecture allow us to be flexible, to work fast and agile on new use cases, and to develop solutions for our stakeholders without requiring to invest so much time into our architecture and into our operation. And of course, we have identified that our company, as most of the other utilities in Europe, we are not focusing on innovation. We are focusing on managing and running and operating an efficient and reliable network. Therefore, we need always to focus on the return of investment. So we don't aim anymore for big platforms, for big projects that allow us to reshape the networks, but we are looking to small projects that ensure us that we are capable to reach a return of investment, a positive business case, but from these projects, we can add and multiply our achievements by identifying similar cases in the future. So here I would like to show you an example of the progress that we have been dealing during the last years, where we started just with small projects that can ensure the creation of value with analytics. Then we move towards projects that can automate these analytics on the cloud. And we move towards real-time analytics. We move towards long-term scenarios with hundred thousands of calculations. And today we move towards create value from AI and machine learning. And always with the focus of multiply these achievements. Because working as an interdisciplinary team allow us working on these use cases, but at the same time identifying potential use cases that could totally profit from the development that have been already done for these projects. So based on these lessons learned, I would like to show you how we are today and what we have achieved in the AI and machine learning world. And also, I would like to show you the difference between the solutions that we have developed in-house, the solutions that we have developed together with other partners, and the solutions that we have developed directly as an external provider. Because we believe that for every single use case, we should really analyze which type of solution fits our requirement and what is the best way to develop it within the culture and the requirements of our company. So, first of all, I would like to show you the solutions that we did in-house. And on this field, we believe that in-house we can build our own models using AI and machine learning. And for what we can build our own models, we believe that we can build our own models for standard load profiles in order to implement a more efficient network planning. And we believe that basically because maybe as a difference as other utilities in Europe, at BKW, we are starting right now with our smart meter rollout, and we have less than 20% of our customers with smart meter. But that doesn't mean that we don't want to implement already optimal network planning with this time series data. So what we do is that using the available data that we have today, we try to develop different standard load profiles that represent all our customers. And as we are directly in contact, or the subject expert matters is within our team, we could also identify that we don't require just to provide standard load profiles. We really need to categorize every customer for a realistic network calculation. So we further develop this method by classifying every single profile with our customers' input data. So we try to identify which data are available for the customers who don't have a smart meter installed. And we try to build a random forest machine learning algorithm in order to identify which cluster or which standard profile represents this customer the best. So what we did, we built several machine learning models based on the parameters that we can use and based on the different clusters that we have developed. And we could see that we are capable to reach really acceptable accuracy when we use all the parameters for the different type of clusters. And that using this information that we can collect for all our customers, we can improve our network planning. Nowadays, we're still working on this case by trying to develop further this solution with more advanced artificial intelligence solution, and also in order to build infrastructure in the cloud in order to profit from parallelization and high computing performance algorithms. We go further, and here we believe that nobody better than ourselves and no better place as in-house in order to develop this type of specific solutions for our asset management and other stakeholders. On the other side, we also go further with artificial intelligence for document classification. For this project, we also want to work in-house because we believe that document classification has a big potential, and that the cases that we are starting to work today, we can work or we can identify additional cases on the future and we can multiply the achievements that we do today. And also we believe that for this type of cases, we require expert support. So for this project, we work together with a startup specialized in AI called Visium, set in Lausanne, in order to profit from document classification with AI. So for this project, first of all, we identified our use case. And this use case is what we call the easement contracts. The easement contracts, or what we call in German Dienstbarkeitsverträge, are the contracts that we do with the different landlords when we want to build assets in their parcels. So basically, as shown in this example, when we want to build an underground cable, and this cable goes through 3 different parcels, we need to do 3 different contracts with each landlord, where we ensure that our asset will remain there for the average life cycle, let's say 40 years or more, and that no matter the case that the landlord change, we are always allowed, and it's always clear that that asset remains there, and any further construction or project on this area should consider this element that we have built there. So as you can imagine, we have been writing these contracts for the last 125 years, and we have a lot of contracts in paper that need to be digitalized. But on the same time, scanning a paper doesn't mean that you profit from this digitalization. For profiting from this digitalization, we need to extract the important data that is relevant for us. And of course, we need to filter the non-valid contracts that have been written in the last 125 years. Of course, when an asset no longer exists, then these contracts are no longer valid and we can directly sort them. So in order to profit from digitalization for this process, we need to improve the access to the data. We need to increase the quality of how we analyze and process the request. And most important, we need to reduce the cost of the process. So how we did identify this case using AI? As always, analyzing what we would do if AI wouldn't be possible. And in this case, we started by digitalizing manually 10% of the contracts. So during the last 2 years, 10% of the contract, let's say around 20,000 contracts, have been digitalized. And the first estimation show that in order to digitalize 100% of these contracts, we would require a massive investment that will, of course, generate that no value would be from this digitalization generated. And we would require more than 5 years of non-pleasant work, because, of course, nobody wants to work by reading 200,000 documents and writing on a Excel document what is the state of each document. But on the other hand, we are not talking about a simple AI solution, because here we are talking about 200,000 contracts written on the last 125 years. We are talking 2 different languages. We are talking more than 100 different contracts. And of course, some of the documents include handwriting, remarks, and even non-readable elements. So for us, it was clear, as previously commented, that we were not capable of deal with this problem alone. And we worked together with a startup, and we implement the following process. We decide to start a study case where we scan around 500 of the most complicated contracts. We use an AI OCR and ECR recognition in order to extract text, figures, and relevant information from these contracts. With our experts, we define the rules and the requirements that we need to consider in order to extract the important information of these contracts. And based on this information and the 10% of the contracts that have been already digitalized, we built a machine learning model that enable us to extract this information with the correspondent confident value for every single extraction, and to add this information into our database so our experts can profit directly from this information. So at the end, how it looks like we have an unstructured data, and from this data, we are capable to obtain structured data where our experts can profit with. And of course, we are not expecting to automatically read 100% of the contracts, but just that we are capable to correctly identify more than 60% of the contracts, it would be a massive success. And of course, as we can see here, this is just one of the business case that it's possible through document classification. So we are really looking forward from multiplying these achievements on further business cases. And here I would like to present you the last case that I will be presenting today, where we use AI for visual recognition in order to classify and identify defects directly from pictures from our assets. For this project, we use directly an external AI solution developed by eSmart System, a company located in Norway that had already several experience and several pilots with utility all around the world on this field. So here, as most of you are aware of, we have two main reasons why we are trying to profit from AI on the visual recognition field. First of all, the current inspection methods are costly, expensive, and even dangerous, depending which line we need to analyze or inspect. We need to consider so many safety requirements. And on the other hand, we don't profit as much from these inspections because we cannot create so much data insights from the process that has been working from now. Because basically until today, we just classify the defects that our experts recognize, but we cannot classify and evaluate all our assets from our network. So what we try to do together with eSmart Systems is turning this inspection data into asset insight. So in one side, we want to improve and reduce the cost and increase the efficiency from our inspection work. And we want to optimize and generate value from the data that we are collecting. For this process, we gather the data, in this case, high resolution pictures. The AI from eSmart will analyze and classify assets and defects. And at the same time, our experts will inspect and verify these estimations in order to strengthen the AI and calibrate it with the type of defects that we analyze during the last years in our company. So then, not just the defects, but every single classification will be exported and integrated in our system. Why we decided to use an external AI solution for this case as opposite as we decided on the previous cases? Here, the main reason is that AI solutions on visual recognition require big specific data sets. On the previous case for text recognition, we could already profit from the development done by Google, by Microsoft on OCR and ECR problems because they already develop models on standard universal text. But in this case, we want to analyze transformers, we want to analyze isolators, and that is a really specific data that we would need to collect and classify ourselves. So we believe that the resources that it would require would be too high, and possibly it could not be compared with the results developed by startups as eSmart, because they have the opportunity to work with other utilities. So the number of pictures that they are capable of analyze will be always on a scale of 10 to 100 higher than what we can do ourselves. So we believe that on this case, external AI solutions will always be better than doing it on ourselves. And what is really important for us is not just that we are using a better external solution, but that we can use it and include it and build over it. Let's say that we cannot have just a closed system that we have to work inside of it, but that we can include it in our process. We can inject data on it, we can export data on it, and we can profit for different business units as asset management, as operative maintenance, and different use case can be built on top of that. And of course, that's not the only thing. Even that we accept that an external solution has more potential than ourselves, we will always challenge them in order to validate that they are enough good and we can use them. So how we are today? Today, we already run this external AI solution on a small data set. And the first results show that the assets were correctly identified and classified, and potential defects were correctly identified, but with the flag that several false positive were also identified. For this purpose, our experts will classify a training set, so we can already set the threshold that we want to consider for defects in order to calibrate the AI into our own requirements. This calibrated AI or supported AI will be tested on a new data set, and in parallel, we are building and formulating a business case in order to ensure that we are capable of generating value from this AI solution. Because it's not enough that the technology is fancy, it's not enough that the technology is good. Most important is that when we integrate it in our process, we generate value from it. So that's the main point and the main requirement that we are considering for every single use case with AI. So now that I present you all our cases, I would like to summarize and conclude with some of our suggestions or lessons learned that we want to share with all of you. First of all, what we have learned, what we believe is the most important lessons learned, is that you must accept your company culture and strategy, and you should not try to reshape the future alone. If you're working on a data science group within your company, you need to accept and understand how your company is working and what your company is looking for, because AI is a trend word, but that doesn't mean that your stakeholders are looking for AI solution. That is really important to understand. On the other hand, it's really important to be flexible and agile. What we have experienced is that the requirements on innovation projects will change really fast, and you need to accept them, and you need to try to understand and to build a flexible system that you're allowed to shape your solution in order to fulfill the new requirements that are coming. You cannot expect that you will have fixed requirements when you start a project and the success of your project will be based just on these requirements. Be always ready to fulfill new requirements that were unexpected at the start of the project. And as commented before, the main focus with AI should always be generate value. We have experienced so many times that some stakeholders come to us asking for a specific case that they believe AI could solve, and then finding that simple solutions with simple calculations or simple regression models could generate more value than investing time on a complex AI solution. That's really important to understand and to accept that focus is generate value, not developing AI solutions. And of course, in our own experience, in-house and external solutions can be both successful for same type of companies. And here what it's important is that you analyze the requirements and restrictions on the potential of every single solution, every single case, and then you try to define for your own culture strategy of your company which type of solution fits better your problem. And in order to end, I would like to add my personal findings regarding this journey. And what I really find interesting is that in utilities, don't ever expect external parties to understand you and fulfill your requirements as you would do yourself. Because even that all of us, we are network operators and we operate similar networks, during the last 100 years, we have built so many specific requirements that we cannot expect that a software provider can fulfill every single requirement of all utilities in Europe. So I believe that working yourself in this type of problems usually allows you to be much more flexible and fast than expecting an external partner to solve these problems for you. And most important of all, I believe that within a company, the most important is to share the success. Try to involve the stakeholders rather to convince them to go through these new solutions. And most important, accept that being right is not enough. Doesn't matter how much you believe that you are capable of building a better solution, that you are capable of solving an actual problem, you need to involve your stakeholders. And you need to invest as much time as it's required, because it will be always better invested time, the time that you use involving your stakeholders, that the time that you use building a solution that will not be used at the end. That's one of the most important lessons that I learned, and I hope that you find my presentation interesting. For any questions, don't hesitate to write or come directly to me, and I will try to answer them on the Q&A or during all the day that we are on this forum. Thank you very much, and have a nice day.